Hello, and welcome to Tech presented by KaiZen, where we will explore common cleaning questions and answers. This session has been pre recorded and will include additional FAQs related to this specific topic at the end of the presentation. We hope it is 15 minutes well spent. Let's get started. I would like to introduce KaiZen's own Jack Reinke.
Thank you, Sherry, and thank you all for logging in and signing on to this new Tech Process Control and Optimization series. Today discussing the Kaizen PCS after 25 years in production. Over those 25 years, PCS has been adapted to changes in cleaning chemistries and has certainly withstood the test of time. Let's talk some history first on the development and the concept of the PCS. This did not happen by accident. Historical expertise in the manufacture of aqueous inline cleaners gave rise to the PCS. These folks have a deep knowledge of dynamics of fluid loss through an inline cleaner. The goal of the machine is to keep the cleaning chemistry in the wash tank as long as it cleans and prevent contamination into the rinse. Some of the control elements that govern losses from the machine include drag out and stack losses. Let's look a little bit about drag out here in the control elements, noting that the high pressure mixed spray nozzle technologies these days required to remove tough flux residues from under low standoff components can sometimes go awry and shoot hot cleaning chemistry down the chemiso. Illustrated here in this middle image, an effective chemical isolation is crucial to the success of controlling the process. Not only does the chemiso keep the wash solution in the wash tank, but it also prevents it from contaminating the rinse or isolates it from the rest of the rinse section. Wash baskets likewise can contribute to considerable drag out. The design of a wash basket has a lot to do with how much chemistry it will hold while it proceeds through the wash chamber. As illustrated here, the low gauge wire basket on top with parts spaced evenly apart to assure complete drainage of the wash solution as it proceeds through the wash chamber, as opposed to the very tight mesh punched stainless basket below, which conceals the parts, preventing the wash spray impingement from hitting the parts, and also carries out large quantities of drag out. On the exhaust side, or what goes up, evacuation versus evaporation concept comes into play, where under static evaporation conditions, as illustrated in the chart on the right corner here, there is negligible loss from static evaporation. But turn the wash pump on and you can see how rapidly the vaporized wash solution tends to escape through the exhaust. It can be contained with a passive demister, as illustrated here, which cools the exhaust in order to condense the vapor back down into liquid and drain it back into the wash tank instead of up on the roof. It's an environmentally responsible option. It should be considered for containment of wash solution out the exhaust on inline cleaners. Those are the two primary means of loss. Let's look at what control options are available for the wash bath, broken up into either manual, semi-automatic, or fully automatic. The manual means uses a manual control, manual measurement of bath concentration, and manual chemical additions. This is probably the least consistent, the weakest process control, offering the weakest process control and somewhat wasteful when you bounce concentration up and down, trying to meet your set point from repeated measurements and manual additions. The semi-automatic still relies upon manual measurement of the concentration, but automates the chemical additions. For better control, it too can still be wasteful for the reasons above, but it's a low investment, and especially compared to the fully automatic option, which automates both the measurement of the concentration and automates the chemical addition based on levels in the tank. This minimizes operator exposure and offers the most consistent control, but it does require a capital purchase. I would call it a wise investment. Introduced in 1997 at NEPCON West, the KYZEN Process Control System, or the PCS, enhances process consistency and yields, optimizes chemical usage, and minimizes operator exposure and chance of spills. Since inception, it's offered complete control of wash bath concentration, run data, usage data, and other valuable data to maintain the process, and does so offering remote access to this data with email alert options, so that if you happen to be on the golf course and have your system configured appropriately, you can actually receive a text message or an email notifying you that your wash bath is out of control. But from a more practical standpoint, you can take this remote data and monitor the system remotely, but react immediately to conditions that need attention. Let's look at how the process control system has evolved over the 25 years it's been in service, mainly in response to different soils required and different cleaning chemistries to clean those soils. Over the past 25 years, solder pastes and fluxes have changed in response to more difficult challenges in cleaning, particularly lead-free, no cleans, which today is probably the toughest challenge in cleaning completely. So let's take a look at the evolution of the PCS in response to those changes in cleaning chemistry formulations. First was the type 1 PCS, relies upon refractive index, uses an automated refractometer to measure dissolved solids in solution on a single phase cleaner, and chemical additions from the PCS are made when the wash pump runs and the wash tank capacity permits. The PCS is programmed with the dimensions of the wash tank, so it has the volume and knows not to add anything while the tank is full. The concentration by refractive index is still a manual option available in either the analog or digital handheld refractometers, one of which I still carry in my car today for use in the field. Next is the phase separating chemistries that gave rise to the type 2 design of the PCS, which determines concentration by measuring differential density or split of two-phase cleaning chemistries. This illustration of the manual test shows just what's going on automatically in the PCS, which is designed with a black box chamber, sampling chamber, in which this same process takes place. That is, the bath is sampled, entered into the box, and then allowed to split, where differential floats then translate that separation into an electrical signal. And by the way, I still carry one of these split kits in my car. And then finally is the sonic velocity method, which is the basis of the type 3 piece. This uses rapid repeating sound waves sent through both single and two-phase chemistries to measure concentration on well-mixed, specifically calibrated cleaners anytime the wash pump is on, and again, makes additions only when there is capacity in the wash tank. It measures many times a second as opposed to hourly with the type 2 PCS, and it also eliminates the need for the black box sampling chamber. Um, it also does not call out the bulk makeup additions, as does the type 1 and type 2 PCS. That same sonic velocity technology is available to as KYZEN ANALYST data services for remote access to data, especially if audits are in tune. It can be used to quickly comply with customer audit requirements if and when those are necessary. But rather than steal the thunder of those coming after me in this series of process control and optimization, I suggest you come online to see future talks in the series by those talking about ongoing advances in wash bath control technology. So, in conclusion, Process control is important and a PCS makes it easy, assuring consistently complete cleaning while maximizing efficient use of expensive, environmentally safe aqueous cleaning chemistries. Some frequently asked questions on this topic. Can the PCS run any chemistry? Now, the type 3 PCS must be calibrated for each product before it can be functional or controllable. Most products are controllable by sonic velocity, but some are not. With rare exception, all Kaizen cleaning products have been calibrated to control via sonic velocity. Chemistries from other suppliers must be evaluated on a case by case basis before it can work with the Type 3 PCS. Can an upgrade from a Type 2 to a Type 3 PCS offer savings? In the case of one example in the field, a customer was monitoring his usage carefully with a PCS and upgraded from a Type 2 to a Type 3. It reported saving about 0.14 gallon per hour of chemistry as a result of that change. We believe that's the result of chemistry conservation because of the lack of any bulk makeup additions required for the Type 3 PCS, unlike the Type 1 and Type 2, which call for bulk additions, thereby conserving chemistry and leading to that reduction. So that customer saw annual, based on their usage, their annual usage of the chemistry, saw savings of about 400 gallons and almost $25,000 worth of chemistry that first year they changed. What kind of routine maintenance is required for the PCS? Very little daily maintenance is required, but you should assign an individual responsibility over the machine as a someone to take command and ownership. So that basically put a guy in charge. The PCS is access into the PCS software is password protected to avoid random changes, arbitrary changes to the adjustments on the PCS. But by way of routine maintenance, simply flushing out the float box with every bath change, and then checking the drum tube uptake assembly for make sure the floats are in effect, as well as replacing an O-ring in the quick disconnect fitting every drum change is about is really about all you need to do. But I do refer to the Kaizen PCS Basic Operation and Maintenance Manual for full details on the operation and maintenance of the PCS. And finally, how many Kaizen process control systems are in the field today? We estimate between 200 and 250 units have been sold into the global marketplace since 1997, all holding wash bath concentration tight within a plus or minus 1% range and offering customers savings from enhanced process control. And Sherry, I'll turn it back over to you. Thanks again, everyone, for signing in and watching today's Tech to Tech session.
And thank you, Jack. Thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you just as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox? Or do you know someone who will benefit from these sessions? If the answer is yes, then just go to tech2techbykaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.